Here we go. Welcome.
Oh, here we go. Nice.
Here we go again. Welcome, everybody, to the show. This is Containers from the Couch. I'm sure everyone watching has been watching us forever, all 4, 5, 6 weeks we've been doing it. But we want to thank everybody for joining.
We're up to season 3, I think.
We're just indefinite here. There's no seasons. We
There's
just
four more to go.
So, so obviously, containers, we talk all things containers on AWS, containers, we talk orchestrators, but we go beyond that. So today is a special day, and probably going into tomorrow and potentially even another day, but we're going to talk to our machine learning friends. And actually, this show is all powered by machine learning and AI. None of us are real. We're all powered by Kubeflow. Just kidding.
Adam bot.
We're real humans. I'm kidding.
I mean, real is in your Twitter handle.
Right. So that alone means I'm real.
That proves it.
It's all proof. The proof's all right there. So anyways, we are going to be talking. Is it Kubeflow or Kubeflow?
Oh, you bring a dynamic question there. That reminds me, kubectl or kubectl or kubecontrol or I don't know.
I've heard kubectl. That's pretty popular back at the office.
Yeah.
So I think that would make it kubecontrol.
Okay, so Kubeflow. So we're going to talk about Kubeflow. Or Kubeflow.
I can't deal with you saying it that way.
Or Kubefluddle. Kubefluddle flow. Anyway, so we have a special guest. As you can see, there's Brent Langston, myself, and we have Peter Dalbhanjan. I hope, Peter, I'm doing
you got it. You got it. Yeah.
Thank you. And Peter is a specialist solutions architect who is going to talk to us and walk us through the beauty of Kubeflow on EKS. And he's going to walk us through EKSWorkshop. There's a section on this which we'll share in the chat in just a moment. But Peter, why don't you maybe do a quick introduction, and then I say let's get right into it, because I know this is a pretty deep section.
Yeah, absolutely. So thanks for inviting me. I've been a big fan of the show. I watched a couple of episodes, and you guys are super chilled. That is awesome. I hope to keep that same demeanor on my end. I'd like to keep it beautiful, like you said, Adam. So we'll see what happens there. So let me go ahead and introduce what we're going to do here for this hour. We're going to talk about Kubeflow. We'll talk about how to run your machine learning workloads using Kubeflow. And I will be talking end to end, and also I think we have questions that come in, so we can answer those questions as well.
Yeah, we have a chat, and by the way, Sathya is back today, so welcome back, Sathya. Good to see you again. And then also, I guess it's morning where Sathya is. We could make guesses, but it must not even Hawaii, maybe.
Jealous.
But then we have Palio saying evening. So and Rudy86 evening. Texan Raj saying hola. Right back at you, Texan. I'm with you.
My goodness.
Hope you're getting some of this rain, by the way. And Wari21, good to see you again, man. The gang's all here. Right on. So I have a question. What is machine learning? I mean, let's just, for those that don't even really understand what it means, what's a simple way to describe, machine learning?
Right. Yeah, so machine learning is, there's several explanations on the internet. There's deep learning, there's several mechanics of building machine learning. I think when you talk about machine learning is about automating a certain piece of workload, right? So whether it's text-based, where you're interpreting what is on an interface and then providing sentiment analysis, right? So it's pretty common in credit card industry, I would believe. or if you're in autonomous vehicle space, where you use the data that is provided to you, whether you're driving a car and it's automatically driving based on the images that it sees. So that is machine learning application, right?
I've
Um,
heard I've heard someone describe it, and tell me if this sounds about right. I'm sure it's not a perfect description, but I've heard someone describe it as sort of like just think of like 1,000 true false questions that help you decide something about, I don't know, an object or whatever, that help you make a decision. And when
yeah.
they described it to me that way, I thought about like, so I used to travel a lot. Haven't been traveling these days, but back when I traveled, I would look at an airline seat map and I'd be like, okay, the first thing that I want to figure out is, where is the row that has the most leg room. The next
Mhm.
thing I want is a window. The next thing I want to figure out is it a two person or a three person, are there any opportunities? So like I almost had this algorithm, and I would just sort of run down my list, and every question was basically a true false. Yes, this is available, or no, it's not available. And based on all that criteria, I would make a decision about what's the best seat choice for that particular flight. And I think that sounds like what machine learning kind of does, right?
Yeah.
You build an algorithm like that.
Yeah. Yeah. So you use the frameworks that are built by the machine learning community. So there's several frameworks like TensorFlow, XGBoost, PyTorch, and there's tons of them. And each machine learning application uses certain set of those frameworks, right? So not
Hmm.
all of them are interchangeable. So when you write an algorithm, what you create is a model, right?
Hmm.
Think of that as an application that you would be putting in front of that question that you were saying, right? What is the best seat for me?
Hmm.
So you get a model, and then you send data to it, and then make prediction. And that prediction is what will give you an AI way, and an artificial intelligence or machine learning way of responding to the question that you asked, right? So a fully automated way, and there's tons of applications that are being built, and I think we're still just scratching the surface. This is a
Yeah.
huge area.
Yeah.
There's several companies that are still growing, and they're building tons of applications in terms of machine learning in order to solve really cool problems.
So
Yeah, and
then, go ahead.
I was just going to say, I think that the thing that's missing that we haven't talked about is just the data, right? So it's great that you have this idea and you have all these true, false, all these questions that you want answered, but in order to answer them and to, deliver a confident result from your model, you need data, and you need lots of data to keep training that model.
Yeah.
And I think to do that all on your own, without, I'm sure we're teasing this up right now, but if I were to do this all on my own and try to figure this out, it's pretty complex. And this is, I think, why the community has come out and built, things like Kubeflow and we have Sagemaker to help solve some of these problems. So the people who want to really build these models and train them can have these frameworks to help speed that process up for them.
Yeah, I agree. So, considering where does Kubeflow fit into this, the conversation that we've been having is, few folks, open source enthusiasts, people who work at Google, Spotify, Amazon, all of these developers thought about, let's take so these are the frameworks that most of the machine learning engineers would use in order to build their machine learning workload. Why not take those Kubernetes, use Kubernetes in order to host those, take all the operators, so there's going to be, when you're going through your data lifecycle management, like a sort of like ETL on top of your data that is coming in, you want to clean it, you want to, transform it and use the data that is interesting to you while you build your machine learning workload. There is an operator for running Spark jobs on Kubernetes, right? So take all of these operators and then build a tool which gives a simple way of abstracting, installing, but in abstracting all of these components of infrastructure that a machine learning engineer would be using. So typically what you would see is, a machine learning engineer would start from their laptop. Maybe they use Docker in order to run their machine learning application. But that's where they would start, right? They would install Docker, maybe Docker Kubernetes engine, and then something like Minikube, and then you would go and load TensorFlow and all the tools that are required in order to interpret your language, your algorithms, right? And then you would build a model that works for you, right? And once you want to put it into production, and that's where you would look into cloud, right? So you would want to go and take a look at, getting this infrastructure on demand from the cloud, and that's where Kubeflow comes in, right? So why not just go simplify the installation, updates, create an abstraction layer in between all of these machine learning tools. And so Kubeflow is essentially machine learning tool set, right? It's a set of tools that are in use by data scientists.
Sounds kind of like it brings a sort of DevOps approach to the whole space, abstracting away the undifferentiated heavy lifting.
Exactly.
And that's pretty awesome. So is Kubeflow the only choice?
No, that's not the only choice. So there's several open source projects that are out there. Kubeflow is the popular one, and we are a big proponent of Kubeflow. We do want Kubeflow to be successful on AWS, and we have customers who are using Kubeflow in order to build their machine learning workloads. But there are tools, like there is a tool that is built by Lyft called Flight. That is another choice. There is Airflow, which is also an open source work. I think it's built by Airbnb, if I'm not wrong. But there are several different choices for you, open source solutions, right? So they all cater to doing really, well-built machine learning lifecycle for you.
And then I'm sorry. Go ahead.
Now, I was just going to say, so those are the open source choices. Now, if you're looking for AWS, like AWS managed solutions, right? So we always have AWS managed solutions. We have a ton of choices on our end as well. Primarily, we have Sagemaker, which gives you an optimized way of running your machine learning on AWS, right? So you could start there. You could start with Sagemaker, and you can build your training model. They've got really good features which can give you like optimized way of creating the train model using Spot instances, right? So you don't even have to think about, how do I run this infrastructure using Spot or whenever I want to train it. And then you can create an inference endpoint. So they have all of those type of features on SageMaker. But like I was saying, Kubeflow is another choice. Typically, we see, and I might be jumping ahead of the question here, but next question could be, why use Kubeflow, right?
That sounds like a pretty good question. I was about to ask that.
Yeah, I know. So
you could feel it coming.
Yeah. Typically, we see customers who use Kubernetes in order to run their microservices workload. There's actually 4 use cases that I can think of that customers can use Kubeflow, and they want to use Kubeflow. One is, they want to standardize Kubernetes, right? They've been running microservices on Kubernetes. They like it really well. They've operationalized Kubernetes. And they know, they live and breathe Kubernetes. So that's one option, right? So that's why, customers tend to use Kubeflow. The other one is hybrid, where you want to run workloads on-prem as well as in the cloud, and you want to have the same layer of Kubernetes. You can have Kubernetes running on-prem, You can run EKS, which is upstream Kubernetes, right? And you get the same level of experience. You can use the same type of tool sets, and Kubeflow sits right on top of Kubernetes. So that's the second option. The third one is burst. If you're running majority of your workload on-prem for whatever reason, maybe due to compliance or proximity to data, and you want to burst into the cloud when you scale, that is the other one. Yeah, and I think there's another one. I have to look.
I mean, those are three pretty
Yeah.
solid cases, right?
The last one
Makes
is
sense.
open source affinity. Like if you've got developers who love open source tools, and they do build a lot of cool tools. So if you have invested into open source, and that is when we see Kubeflow as a way to run their machine learning workloads.
And that matches up very closely with reasons why people pick Kubernetes in AWS to run their microservices. You know, that a lot of times it'll be because they want that same experience in their data center or wherever else they happen to be running. So to get that standard experience, they'll bring up an EKS cluster or something and have that Kubernetes experience wherever they happen to operate. So yeah, I mean, I think that makes perfect sense. And I like that you contrasted with SageMaker, being a managed service. So, because I think we hear that a lot too. Why would I use Kubeflow and sort of do it all myself versus using a managed service, or vice versa? Why would I want to use a managed service when I could have total control? And I think that answer is kind of very similar for every managed service. It's like, how much do you want to tweak and control, and how much do you want to let other people manage for you?
Yeah.
So
now, one thing I want to make clear. Sorry to interrupt there, but I want to get this point made clear. It's the choice is not either or, right? You don't have to go with only SageMaker or only Kubeflow. We've built integration between these services. So if you want to use Kubernetes, if you want to use Kubeflow, and if you want to use SageMaker for the good things that I spoke about earlier, then you can do that, right? So we've got a couple of ways to do that. There's SageMaker operators where you can live and breathe Kubernetes, and you can use SageMaker as Kubernetes native APIs. So that is one way to use it. And then there is also SageMaker components, which I think we just GA'd that last month.
Nice.
Which is, you can take the SageMaker properties and then use that from Kubeflow, from your Kubeflow pipeline, so that you can build a machine learning workflow using SageMaker. So you can use Kubeflow to define your workflow and then say, hey, Kubeflow, whenever you run this training job, run it on SageMaker, right? So you can use both of these in a homogeneous way.
That's very cool. That's great integration. One other thing, and I think probably we should get started with some of the demoing too, but I want to say that, when I think of machine learning, especially in the cloud and AWS, we have these higher level abstracted services too, like recognition or, Poly. We have a lot of these kind of generic machine learning use cases where, you just need to transcribe something. You have text and you want to transcribe that. A lot of times you could just use these higher level services where it's just an API call away. You make an AWS API call. Here's my data. Now do the cool ML stuff and just give it back. Or, so that's one. And then as you get deeper, when you have more customized use cases for your machine learning needs, I think that's where then the Kubeflow, the SageMaker comes in, because you're building a model that's a little more specific to something you need that's not in the generic high level ML offerings. So.
Yep. Yeah, I agree. If you want to customize, if you want to have total control over the model that you're building, if you're building a machine learning lifecycle from end to end, where it continuously improves based on the new data set that you get, because it's essentially ties back to software defined lifecycle, right? So microservices became popular because the recommended way of building a microservices is to have an independent pipeline for each of the service, and that service can only do one thing, right? So machine learning uses the same kind of philosophy where you want to continuously iterate and improve the model, or else you're going to have a really bad day. I mean, there's been cases where bigger companies like Amazon has made the machine learning hasn't worked for certain things, right? Google hasn't, it hasn't worked for certain things. And Microsoft, I think they had a chatbot which went complete Nazi within less than 24 hours.
Wow.
So there's been stories like that.
That reminds me of a joke. Why are neural networks better than humans?
Oh, I
it's going to be a cheesy dad joke, though.
Because they actually learn from their mistakes.
Oh, good. That's good. And very relevant, Brent.
I know,
I agree.
right?
Good joke.
So why don't we kick this couch out of the way and get down to the screen share? What do you think?
Yeah, let's do that.
Did you practice that line, Brent? Because that was pretty awesome right there.
You like that?
I like that. You got to use that more.
That was totally improvised, but I think I'm going to use that. That's a pretty good transition.
Well done. Well done. Anyways, go on. Sorry.
Okay, so I'm guessing everybody is familiar with EKSWorkshop.com. That is where we're going to run these tutorials from.
If you're not, you can find it at EKSWorkshop.com.
Right on. Yeah, so you would go to EKSWorkshop.com, and they're organized in a sensible way where there's an intro part, there's start the workshop, launch an EKS cluster, and then there is sections, right? Beginner, intermediate, advanced. The machine learning chapter and a bunch of chapters are all under advanced. So the chapters that we're going to go look at for this hands-on experience is the machine learning using Kubeflow exercises, right? So you would go there, go to this right arrow. So I've done some preparation, and the preparation is essentially which is given here, where I went to getting started guide, and then I went built an EKS cluster, right? I did this just the basic ones where I didn't have to wait for 15 or 30 minutes there. But once you have that, let's go ahead and first thing we're going to do is we will increase the cluster size, and I'll talk about why we do that. So we'll just go ahead and run this on my Cloud9. So I'm going to be using Cloud9, which is what we recommend in EKS Workshop.
Yeah, and
Brent and I talk about it all the time.
Yeah, if you haven't started using Cloud9, what that's going to give you is sort of a clean room environment to install all of this stuff. And that's going to be really handy in this particular situation because you're going to be installing some software to try stuff out and that sort of thing. And you don't have to necessarily then have it all installed on your laptop or wherever you work and have to clean that off later. You can just throw the Cloud9 instance away. So definitely, investigate that. And for me, it's like really, it's what I use every day. So it's been a game changer for me.
Yeah. Yeah, I like it because it keeps a snapshot of the work that I've done, from whatever I was doing before. And, I create a bunch of demos for customers, right? So, maybe there's a demo that I built a couple of months before, and, there's a need that I have to go ahead and pull that up really quickly. So I just go Cloud9, EKS, everything is set up, and then, just show the demo and keep it there. So, or maybe tear it down as well.
We are getting a request. Can we zoom in a bit?
Yeah, absolutely.
Appreciate it.
Yeah, it gets harder for the person demoing, but it's helpful for those watching.
Yeah.
Is that better? Or is that
I think it is. He says thank you.
All right, cool. Yeah, so we just increased the size of the cluster. So let's just do kubectl. What do you guys prefer to say? Kube control? I don't
I
know.
say cube control,
Okay.
but
I say it because Brent says it.
that is not a reason to do anything, by the way. That will not get you very far in life.
I don't know. I just say whatever comes off the
Yeah.
tongue easiest.
If you feel like cuddle is the right way to go, then that's totally fine with me.
We accept it here.
Yes.
Yeah, I'm used to saying kubectl, so if I mistakenly say that, don't get offended.
No offense here. We're good.
Okay, so the nodes are coming up. They're not ready right now. Let's give a couple minutes. And what I'll do is, in the meantime, I'll walk you through what we are doing here for the maybe 5 minutes, right? So we just increase the size of the clusters. So by default, if you follow EKSWorkshop, you come up with a standard environment, which is 3-node EKS cluster. For this purpose, for Kubeflow, we go and increase the size because Kubeflow, it goes and installs a whole bunch of stuff. And you'll see that right away, right, once we do the installation. It's for that. And also, we're going to create a few things. We're going to create Jupyter Notebook, which is an interface. If you're a machine learning engineer, you would use that in order to write algorithms, right? Author algorithms. And there's a way to share your notebooks. So we'll go over that in the next chapter.
And Peter, I had a question. So, I see we just increased the cluster size here, but I mean, obviously machine learning GPU is important to training like machine learning workloads. At any point, do we start integrating any type of GPU in the picture here?
Not in the workshop, but if you've written algorithms that require GPU, you can go and create a node group that is GPU specific, like P3, P2 instances. So typically, that's what I would do because GPUs are not cheap, right?
Yeah.
The ones that we use are, they're just basic M5 larges. I think for Kubeflow installation, to be honest, you just need 2 M5 large. But we just create 6. We go with 6-node because like I was saying, we're going to be doing a lot of creating a lot of stuff. We'll delete all of this once this whole tutorial is completed. But just to give some room there.
And Amit points out, Amit, I'm just going to call you Amit. I don't know how to pronounce possibly your last name, but he just says Autoscaler. And I think what he's getting at is it is quite possible that you could have like a tier of nodes that autoscales up when you have GPU work that needs processing, and then it can scale back down when that's empty. And then while we're paused, Tag I don't know. Says, is Cloud9 free to use? And sort of. So what you're paying for when you're paying for Cloud9 is you're paying for the EC2 instance. So it doesn't cost more because that EC2 instance is being managed by Cloud9. And what Cloud9 does help with is it'll actually like put your EC2 instance to sleep and wake it back up based on the amount of like when you try and connect into it and activate it to use it. Or if you've been gone for 30 minutes, then it'll put it back to sleep. And you're not paying for it when it's asleep. So it can help in that regards. And then it's also able to bring up an instance that can be running, from the free tier.
Yeah.
And free tier EC2 is free for a year, basically. I do think that for this workshop, we need an instance that is slightly bigger than what you could run in the free tier for a year, but I think you could still run it in the free tier for some shorter amount of time. So definitely check out free tier for EC2 and look at, kind of how that works. And then you'd be able to run, thanks, Adam. You'd be able to run your Cloud9 instance within that free tier.
Cool.
Let's do it.
Yeah, so so the nodes have come up. As you can see, I've got 6 nodes here that are saying they're ready for prime time. So let's go and do the installation of Kubeflow.
Yeah.
So the first thing we're going to do is, so there's a release version that we're using here, right? So and we say first go ahead and download this tool called KFCTL. So KFCTL, it's a binary that the Kubeflow community has built to make the installation process simple, right?
So we don't say KF cuddle?
So I saw somebody, I think it was Satya, who
Yeah.
said kubectl. That stuck in my head, right?
CTL. Yeah,
Yeah.
totally. I've heard that so many times. Cube CTL.
Yeah. Yeah. So KF KFCTL. But yeah, so we're going to use that. And if you're using your Mac in order to install Kubeflow, to take a look at the binary. It's a different binary. But because this is Linux and Cloud9, we're going to install this.
Mm-hmm.
So we'll just click on this neat little button there to copy paste and do the installation for KFCTL.
Adam, so we have a question from Stitchy E. Adam, do you know the answer?
But where does what install? I'm sorry, that's what I'm trying to.
Oh, that's fair. I'm guessing the KF cuddle.
Oh.
Or maybe Kubeflow itself.
Yeah, so let me clarify that. So currently we're using, think of this as your laptop, right? The Cloud9 that I'm using. That's what you would use in order to access your Kubernetes environment or Kubeflow environment. We haven't installed anything yet, right? So the first thing we did, we installed KFCTL, which is a package which will go and install Kubeflow, and the Kubeflow is going to be installed on my EKS cluster that I just stood up, right?
And specifically control plane or worker plane?
It's going to install on worker.
Yeah, and the reason I think, one sort of bit of reasoning you can use, Stitchy E, is the fact that we're doing this on EKS is kind of a tip-off because you typically can't install things onto the control plane of a managed Kubernetes service. So it's already set, no adding stuff to it. But Kubeflow runs from the data plane, so you can totally install things that run from your workers without issue there. And Kubeflow is just another one of those things.
Yep. Yeah. So we just installed KFCTL, KF control. And we're going to
get
use
every variation in before the end of the show.
I don't want to offend anybody, man. I'm just being nice here. So the next thing we're going to do is we will create some bash environment variables. So let's take a look on what this is doing. So this is all for this installation only. So if you need to change any of these parameters, you can certainly do that. What are we doing here? So my cluster name is EKSWorkshop-EKSCTL. So I just stored it in an environment variable. And I gave it another name, KF name. And then I'm calling a base directory. That's where I'm going to install or build the installation files for Kubeflow. And I'm calling the kfdir, or the directory where that's going to be stored, is going to be under environment under my cluster name. And you'll see that when I run the next command. And then I'm going to use a configure. So this is something unique that you need to specify. So currently there are 2 versions of configure. One is the one that we're going to be using right now, which will give you a very basic Kubeflow installation. The other one is this one, which has Cognito in it. So what's unique about each of those versions is so the Kubeflow community starting this year, they enabled multi-user authentication to Kubeflow platform. So they introduced multi-tenancy. And if you want to use that feature, multi-tenancy option, for your Kubeflow so that you can, have users, Brent Langston, Adam Keller, Peter Dalbhanjan, individually authenticating to Kubeflow and having their own workspace. You can go ahead and have your own Jupyter notebooks, so that if I write an algorithm, I can go ahead and share, and only share with Brent, maybe not with Adam, right? So if I want to do things like that, then that is possible, but you do have to use Cognito, which is AWS managed service. It gives you a really nice way of integrating authentication into AWS platform. So we use that mechanism here, but you do have to use a different configuration in order to do that.
So I've seen that situation happen at is a hedge fund where the traders, they're working under the same roof, but they're in a way kind of competing with each other. And so they're trying to like come up with the best possible algorithm that they can, and they're like constantly tuning it and tweaking it and everything, and they will maybe share it with one or two other traders, but they don't want it to just be like completely free for all, available to everyone. So there's a lot of like guarding the secret sauce that goes on at that kind of place. So it's really interesting to see, that is being built into the tooling, just knowing that need is out there.
Yeah. No, this basically came from the user community. When they ask what is the missing feature in Kubeflow, the end users basically said we need multi-tenancy support on top of Kubeflow, or else our enterprise is just not going to allow us to use this tool, right? And that is what we had Kubeflow as before we announced, or the community announced version 1.0 at the beginning of the year. But yeah, so that is one way. There's also another mechanism, and the best way to find all of these documentation is from Kubeflow documentation. So there is a link here, so if you want to check that out. So Cognito is one way to build authentication into your Kubeflow. There's also DEX, which uses OIDC in order to authenticate. So there's other methods.
Cool.
We're just using the basic one. We're not using Cognito because there is a dependency where you need to go and create a custom domain, which we don't want to give that kind of experience for our workshop. You don't have to go and create your own domain name and all of that just for this purpose. So we want to keep it simple for the workshop users.
Makes sense.
All right, so that's what we do here, and in the next next few lines is just building Kubeflow installation. So just let's go ahead and run those and download the configuration file. So this is the configuration file that we just downloaded under my workshop, under environment, right? So if you go and open it, you'll see, so this Kubeflow uses Customize in order to deploy all the Kubeflow components.
And Customize is a templating engine.
Yes. Yeah, it's a templating engine, and you'll see it's basically a huge YAML where it says if you want to go ahead and install certain thing, go and fetch it from the manifest that is right here, right? So you'll see that it installs Istio CRDs, a bunch of Istio installs. So this is a big one. You have to scroll all the way down to see AWS particular components. So there is a plugin that we've built called AFKF AWS plugin. And we make use of certain assumptions in order to do the installation. So we've downloaded the Kubeflow configuration file for the installation. Now we'll use some bash magic in order to modify that configuration file. So let me go ahead and run that, and then I'll say what we did.
It's a lot of YAML.
Yeah. Yes,
You're
it is.
imagining CD Cates, aren't you?
Always. I see Python, and I'm just like the little cloud dreaming.
Yeah.
Someday.
So what did we do here? So we made a slight change. We made sure that the region is pointing to US West 2. Since I am on US West 2, we should be fine there. We added a parameter called enable pod IAM policy. I'll talk about that. We added that one, and then we commented out node EKS node group policy, and we also commented. So we commented a couple of lines here, which is that line and that line, and we added this new line. So what did we do here? So we along the same line when Kubeflow came up with 1.0, we enabled IAM role for pods, which is a secure way to access AWS resources. Because Kubeflow is going to be accessing a whole set of resources, things like S3, things like Sagemaker. As you go through the tutorials that in the next 2 days, you'll see that. So it'll be accessing all of those. And what we do with IAM role for pods, when we specify this line, we can go ahead and make use of that capability, right? So it's a nice way of implementing security and saying, for Kubeflow users, if they are trying to access other AWS resources, you can create a fine-grained access control using a policy, and then you can attach it to those users.
So is this URSA?
This is URSA, yeah.
Nice. URSA stands for
IAM roles for service accounts.
Yes, thanks. Thank you. So I want to address a question real quick. DP the Gray asks, if I started learning containers now, then how long will it take me to understand this level of talk? I still don't understand this level of talk, DP Gray, so I'd say just start now and worry about how long later. You'll definitely be doing pretty well, the more you do this and the further along you go.
And I mean, that's why we have EKSWorkshop, ECSWorkshop, because it really branches from brand new super beginner to advanced, Kubernetes user that just wants to look at, very niche use cases like this. So yeah, you can, it takes time. You're going to have to learn, but go through EKSWorkshop. This is how you're going to learn. You have examples, you're going to deploy sample applications, and that's what's going to get you going. But go through the beginner section first. And I just wanted to add on the URSA stuff. I think, whenever we're deploying containers to these orchestrators, it's really important to limit the scope of what your containers can do. And IAM roles for service accounts is doing exactly that. You're controlling on a per pod basis what your pods can access as far as AWS resources, rather than enabling it on your EC2 instance where all the pods running on that instance can run against those AWS APIs. So it's all about limiting blast radius. So this is just a good policy.
Exactly. Well said, Adam.
Thank you. I had to talk. Thank you.
Now, I do want to, so in some of the chapters in machine learning, you'll see that we still make use of worker node IAM policy. The reason there is because some of the frameworks that we're going to be using, so IAM role for pods, the URSA, like Adam likes to say it, that capability only comes with the latest AWS SDK, right? And I think there's an SDK version that we released sometime this year, and you do need to have that in order to take advantage of that, right? So you need to have latest AWS SDK for things where we don't have control, because we're going to be, we are in open source machine learning world. We're going to be making use of the node groups IAM policies. I just wanted to clarify that. If you see that, don't get alarmed. But our goal is to keep moving towards this, where you get to take advantage of the secure way and the best way of running things in the cloud.
Great point.
Yep.
Great point.
All right, so so we just so we haven't done anything so far. It's just modifying configuration. Now we're going to do one little thing here. We'll install AWS IAM Authenticator. There is a GitHub issue that talks about why you still need to do that. There's a PR, I think. We're trying to fix it. So now, next command is going to go and build and deploy Kubeflow. So let's go ahead and run that because it does take, I think about 4 or 5 minutes to do the installation. You can see here, things populated, right? There's a couple of more directories, AWS_config, customize. You can certainly open them and see all the things that it's going to be installing.
Wow.
It's huge.
Yeah.
So don't be alarmed. There's also a few things that we make assumptions, so you can go and take a look at AWS config in order to understand those. But yeah, so this is going to take a few minutes, and by the end, it's going to say it's successfully installed, and then after that, we're going to do kubectl -n kubeflow get all, which is going to say give everything that Kubeflow is installed, and we'll see what has installed there.
Wow, that's impressive. So all of that environment setting that you were walking us through earlier was all just to help enable this kind of automation, so that we don't have to install 57 things ourselves manually and tweak, all those different parameters and stuff like that. So do it once in the environment, and then have all that get populated out of the environment. It's pretty cool.
Yep. Yeah. So looks like it's finished installing. Let's go and run kubectl get all command, and you can see everything that is installed here. So there's still a few things that are still coming up.
Wow.
Right? They're still getting ready, but if you give a couple minutes, it'll all come up fine. But yeah, so it's hundreds of pods. So several different operators. All the features that are provided by Kubeflow, and we'll walk you through on what those are in a minute. But yeah, so it bundles everything, creates one single installation, and then goes and deploys it on Kubernetes.
Nice. Well, so we're about 10 minutes left in the show. We want to. What do we do after we install it? And will we have time?
Yeah, after we install, what we'll do, we're not going to have time to do the Jupyter Notebook. So what I'll do is I'll bring up Kubeflow dashboard.
Yeah.
I'll walk you through each of those. So maybe we can do Jupyter Notebook, because training and inference will go along with each other.
Mm-hmm.
Notebook is just, you just pull, copy an algorithm, and run a notebook and show how you can, basically author an algorithm. We'll see if we can achieve it. But yeah, let's go ahead and pull up a dashboard.
Okay. Yeah, let's see the dashboard.
We love dashboards, by the way.
Yes. Dashboards are great.
All right. So if you see here what we're doing, we're essentially using kubectl, right? Creating a port forward and saying if service Istio ingress gateway, that is how Kubeflow gets exposed. If you follow the default method, you can go and put a load balancer in front, but remember it doesn't have authentication, which you don't want to do that.
Yeah. So this isn't exposing to the outside world, but this is allowing wherever your workstation happens to be. Allowing it to get into to be able to see the Kubeflow dashboard.
Yep. Yeah.
Cool.
Yep. So only my workstation can access this when I do port forward.
Yeah.
And the way to access that dashboard is you go to preview. If you know Cloud9, this shouldn't be a surprise. But click on preview running applications, and click on this button here, which will make it another tab.
Yeah. And
Yeah.
the port 8080, by the way, that's a specific Cloud 9 requirement. It'll only do that for port 8080. So if you were doing this from your laptop or something like that that's not Cloud 9, you would be free to pick a different port if it, makes you feel better. But for the most part, 8080 on Cloud 9, that's the way to go.
Yeah. So the first thing we're being asked is you need to do some setup, right? So there's actually not much to set up. You just go and specify a namespace. So namespace is Kubernetes namespace, right? So for this one, we'll give it EKSWorkshop as a namespace, and we'll click on finish.
Now, as you do this, I have a question for you. It looks like Kubeflow stores state, right? It looks like state is important here. So is state stored somewhere? What happens if I kill my nodes and I refresh with a whole new fleet of nodes, worker nodes?
Good question. So let me just go and create a new terminal. And I'm going to close this because I already have another tab there. So if you see kubectl get pods -a, there's a ton of things that get created here, right? Mm-hmm. If I want to say grep MySQL, there's a few MySQL pods, right? So there are a few stateful applications, like you're saying, there is a few states, and the state is, let's say I go and create a bunch of pipeline. I'll go through all of these, and so if I go and create certain properties, certain metadata in my Kubeflow, right? All of that gets captured as a state, stateful application under MySQL. So there is a feature called Katib, which is used for hyperparameter tuning. This is a thing in machine learning lifecycle. So for that, there is a MySQL database in order to store all of the things that get created by Katib. For this one, MySQL, there's metadata that gets created. There's artifacts that gets created. So we also use MinIO.
Oh, interesting. And there was a question, are the MySQL pods backed by EBS?
So these are stateful applications. So they use Kubernetes stateful sets. So it's default EBS volume that is available through worker nodes. I didn't customize anything.
So they probably make a persistent volume claim, and then Kubernetes comes and fills that claim with whatever its default is.
Yeah.
And when you build a cluster using EKS control like we do in the workshop, then the default is EBS volumes.
Yeah.
So connecting all that together, the answer is yes, but now hopefully you can also understand, Wari21, how you might want to go and tweak that. If you made EFS the default for your cluster, then they would be backed by an EFS volume. So that maybe is a better choice for you.
Yeah, but we've actually made it even better. So if you want to get rid of these MySQL databases and use RDS MySQL, there is a way to do that, and there is a documentation on how to do that. There's a CloudFormation template. Go spin up a RDS MySQL. Go modify the YAML that I showed earlier, and say, hey, I want to use RDS for the stateful things that gets created in Kubeflow for the obvious concerns that you would have. If something happens to my worker nodes or MySQL database falls through, how do I reproduce it, right? So you can store all of that, offload it into RDS MySQL. Same thing with S3. You can replace MinIO with S3 as well.
Cool.
Yes. Okay. So that's the dashboard. Let me just walk you through so you can read up. So we did this. We just created a namespace. Let me walk you through the dashboard at a high level. Maybe we can take questions after that, because I don't want to run into risk of creating the Jupyter notebook, and we can do that tomorrow as well.
Yeah, let's do the Jupyter notebook tomorrow.
Yeah.
Tune in tomorrow.
because
find out
we are
more.
button up against the time end of time here. So
Yeah.
Okay, so so I can walk you through the dashboard here. So this is a a traditional Kubeflow dashboard. You'll see a few things here on the left-hand side, and it says dashboard and activity. Currently, there is no activity. I haven't done anything. If we remember, we created a namespace, so I can click on EKSWorkshop. And if I created any notebook, it's a notebook service under notebook, then it will show up here as recent notebooks. But yeah, so if you go click on pipelines, you'll see currently it's not showing anything because I haven't created anything. But here is where I can go and create experiments. Right, so experiment. Think of experiment as a project, right? So if you're building an autonomous vehicle model for autonomous vehicle, and if you want to call that as an experiment, you can say that here. You can create an experiment.
Nice.
Artifacts are things that you create within your pipeline, so that gets run there. Executions, I think executions are normal runs that you would run if you have just a single. Here's my notebook. I just want to see if it runs. You can go ahead and do that. I think that's what it is.
So we'll probably be doing some of that tomorrow too, right?
Yeah.
Awesome.
Yeah. So this actually, so pipeline is actually at the end. So we'll have to see whether we do it tomorrow or the day after. But yeah, so we do have a chapter where we'll go through creating a pipeline. A pipeline it's the most critical feature. I think it's the most liked feature of Kubeflow. A pipeline it gives you an end-to-end workflow, right? It gives you a mechanism where you can go and create series of steps, right from data tuning to creating a model to creating an inference endpoint. So all of these are different steps that are required in order to create a machine learning model. And that's what pipeline will give you.
That's awesome. So we have a few questions in the chat. Texan Raj wants to know, is Kubeflow like Jenkins for machine learning? Adam, I think, is probably best suited to answer that since he's the local Jenkins expert.
I would say yes, right? I mean, it's you're building pipelines. This is like CI/CD for ML.
Totally. Yeah. I think the answer is yes too. And DP the Gray says, this is overkill as a beginner in the cloud and container world, but I'm very excited to learn. But I have questions. What should I learn after Docker and Kubernetes? How do I plan the journey forward? And I actually think, CI/CD and delivery and GitOps might be a good place to start. And if you want to categorize what we've begun talking about today, I think Peter used this term, I don't know if it was before the show or during the show, but he called it ML ops. So if this is something that that interests you, then definitely dive into machine learning operations. And if this isn't your cup of tea, but you think just overall learning about the cloud and containers and Kubernetes is the way to go, then maybe dive into GitOps and learn about that. So
yes.
I would be remiss if I didn't close us out by telling you that we will be back tomorrow to learn with Peter, and we'll be diving in even deeper into Kubeflow. And then also we're going to have a container day August 17th, and that's going to lead us into KubeCon Europe. So definitely check that out, sign up, and come back and join us tomorrow.
Thanks,
tomorrow is going to be even awesomer.
That's right. Awesome. All right. Well,
thanks so much.
Thanks, everyone.
All right, thanks,
and
everyone.
We'll be back tomorrow.
See ya. Bye-bye.